Welcome to Lockdown Learner. In this video we will going to explore about memory layout in C. A memory layout is a kind of a memory model which shows where the elements or data of a programming language is stored and how it runs. For example, your local variables, your global variables and functions. And it is also very important to know the placement of code, like from where it fetches the instruction and where it runs the program and where it stores the instruction. So let's get started. So here you can see we have these code sections. So on the left hand side you can see we have stack, heap, initialized data, uninitialized data and text. So let's start from text section. So text section is the section which has the execution instructions like functions or like global variables, and then we have this uninitialized data which stores the global variables which are assigned with no values or like they are assigned with 0, and they are also called as blocks started by symbols because they don't have any value to represent them. And then we have initialized data, and in the initialized data those global variables comes which are like assigned with some values. And then we have heap and stack. So all the below three, text, uninitialized and initialized data, are the sections which shows how actually code is stored in the hard drive or like your static memory. Now once this code is stored, once you start running the program, that program is get fetched from your hard drive, and that is run on the like using the stack and heap. So let's see like how these two memories are dependent. So first let's talk about stack. So stack is a static memory, so that occupies the static instructions which are like present in your functions like local variable, or like you're doing some instruction or for loop, and everything goes into the stack. And then we have the heap. Heap has these dynamic allocations which gives you memory during runtime, and it can also have some dynamic libraries too. So let's move into a practical example. So here you can see on the right hand side we have our code placement, and the left hand side we have this practical example, and you will see later this example, similar example in the Eclipse workspace. So here we have a main function, another function sum array which sum ups the array which gets a pointer as a parameter and the size too, and accordingly it calculates the sum. And here you see this local variable sum, like this local variable sum gets the value from this for loop, and then we have this global variable which actually stores the sum plus this bias value, that is actually 5, which is a global variable assigned with some values. And this global sum is a global variable which has like null assigned to it, like it don't have any value. And again in the main function we call this print function, and we call this sum array, and after calling this we like gets this value sum as a in return, and we print this output. So according to the data section placement, these two functions, main and sum array, should go into the text section, right? And this variable, like this variable should go into the stack, and all the other variables actually, like all the local variables, should go into the stack. And this global variable with like with some assigned values goes into the data section, right? And Then we have the another global variable that is the global sum that goes into the uninitialized data section. So let's see how. So here you can see these are the snippets. In the middle you can see these are the snippets taken from the Eclipse. Later we'll see how we can generate this, and these shows us exactly what we have like discussed in the last slide. This is how these section like these variables are placed in these sections accordingly. And with this we can start with our practical like with the Eclipse workspace. Like two functions. One function is the main function and another function is the sum array. So what does this sum array do is like it sums up the every element of that array and it just returns the result of it. So in main we declare one local variable a and we assign some values, and we have this print, and in this print we call the sum array with this variable which is pointing to the first element of this array and the size of this array. So once this is called, this function will be called, and further this function according to the size we're going to sum up the every element of the array in this local variable sum. And after that the result sum plus some bias value which we have taken 5, that is coming from a global variable, and this value along with the sum is going to add up in the another global variable, that is global sum, and after that this function returns the sum. So here we have like three things you can see. We have these two functions first, and then we have this non-assigned global variables, and this again the second global variable which is assigned. So according to the memory map, this variable which is global sum bias should go in the data section, and this global sum should go in the BSS section, block started by symbol, or like those variables which are global but declared as a with value 0. So these this section will go into the BSS section, and further this sum array and the main function will go into the text section, because these are the like functions, so these all should go into the text section. And further after these functions start executing, they will start running into the stack. So let's see how we can actually know which variable goes into which section. So with the here I'm using a mincw. So mincw gives me like this option, like I can use this flag. You can see X linker, and that flags has this value map is equal to output.map. That means I need a map file. So what is a map file? Map file is a output file of your whole program, which has every section, and it also has how your code is placed into the memory. So everything you have in your code .o or like .object files or variables, global variables, everything will going to go into the map file. And after generating the map file, you can directly see where like at which location your every variable is stored. So let's see how we can add this flag into our Eclipse project. So I have this file map output.map. So I can open. So this is this is how this map file looks. So let's see how you can actually like add this flag in your linker that will going to generate a map output file for your program. So you can see here I have opened the project properties. So in properties there's option C++ build, and under that there's option settings. In the settings I have to go into the tool setting, the first option, and here you can see this like the main option, that is MinGWC linker. So this is the like configuration block for the linker, and here the third option is the miscellaneous. So this miscellaneous has this like option, like I can give my own flags, like I can pass on the linker flags. These flags are like small switches to turn on and off certain functions. So like I have given this flag, that is map equals to output.map. That means I need a map file, and that map file should be created named output.map. So that looks like okay. So I'll apply and close. So then I'll try to build it again. So here you can see in my build log messages, okay, it says nothing to build, claim this. So I'll build this again. So here you can see, like after compilation, this is the compilation, and it try to link. So in the linking, it passes this flag. So this is map output.map. So I can open my debug folder, and you can see under my debug folder there is a file created, that is output.map. So I can open this file directly in my Eclipse editor. So you can see this is the file output.map, and let's try to open this parallel to our code, so it will be easier for us to compare. Let's try to find out this global sum variable. So on the right side I have my output linker, so I'll try to find a global sum. So here we go, we found this variable, and here you can see this variable is like a symbol, and this is the address where this variable is actually present in our output file, and this is the main.o file which carries this global sum. Obviously we have one file, so there will be one object file, and in the like the size of this object file is like this. This is the size, and further this is the section where this whole thing goes. So you can see in the main.o, this variable goes into the BSS section, block started by symbol, like those variables which are global but are not assigned with any value other than 0. So there we go. Then we have another variable, that is global sum bias. So this is the global variable which we have assigned certain value. So let's see where this variable goes. You can see, so you can see on right side, like this variable is again present in the same file, obviously, and then this is the size, and this is the address where it is present, and this is the section, like the data section. So under the data section, this is the initialized global variable, so it is also correct, like it is present here. Then let's search these functions, where these functions are actually getting stored. So let's search the sum array. So here you can see, here we go, again this function is present in the main.o file, and this is the address where this function is, and this is the section .txt text section. So this goes into the text section, and underneath sum array you can see we have the main function, and it also goes into this text section. So it is pretty clear, like how this section placement is done for this code, and this is the like very much static placement, like this is how code is built and this is how code is getting stored. So once you like start running the code, then your code is actually like gets fetched from the computer's memory, and that get placed into the RAM, and further the expansion of the code depends on the like what is your stack size and where you have given the like starting edges of the stack. But usually in like initial programs we don't do that, so we are like totally dependent on the computer's memory map, or you can say the linker, which actually gives us the placement automatically. So let's try to run this program. So I'll run this. So I already have a GDB debugger, so you can also configure your GDB debugger with your code. So here we go. So it outputs sum of array is 15. So this should be result. Yes, it should be 15. So you can see this is good. So let's try to debug this code now. Okay, so I need to configure my GDB debugger. So let's do this quickly. Okay. So here I have to give the path for my debugger. So this is my debugger. Let's try to debug now. Okay, shows. Here we go. So our code has started running, and you can see here, like here in this debug section, this is showing thread 0 and thread like 10 and 20. So it is saying like right now it is pointing to the main function which is at this location, right? So here you can see this whole thing is the call stack. So this is the stack where our function is actually getting expanded, and on the right side you can see this shows the variable, and this is actually showing the local variable. So this is also showing this same stack. So here it is showing like stack is started in the main, and like it is expanded inside with these like this variable declaration. So if I'll go step by step here, so you can see these values are assigned to this variable. So this is a variable section, and let's create a breakpoint. So by like double left clicking, you can just create one breakpoint, and let's play this. So here we go, we have gone here. So you can see we have stacked this function from the main, and we should see this function on top of the main. That sum array should be in the top of the main. Yes, we can see. And again we can see this stack is already getting stacked up. So here we can see this sum variable. So if we go one by one, like when we are actually fetching the variables from this array and storing into these variables sum, so let's go one by one. You can see sum is getting incremented. 16, 15. Okay, once it gets incremented enough, like to the last, it will going to return again. So you can see once it returns, this call stack will also going to return now. So this stack is getting like used, and it is getting destroyed right here. So the only stack we are left with again with the main, and once we exit this function, we'll going to like destroy the main too. So this was the whole point, like to like tell how these sections actually goes into the memory, and how computer actually fetches these section and loads into the RAM to run the program. Hope you like the video, and please don't forget to subscribe.